In 2012, a hacker group that calls itself Team Ghost Shell claimed to have gained access to the servers of 53 universities around the world, including Harvard, Stanford, and the University of Zurich. Resulting in this attack, they were able to publish around 36,000 email addresses and thousands of sets of confidential user data, such as usernames, passwords, addresses, and phone numbers of the university's students and staff. But how did they manage to access the university's database to retrieve all those informations? The answer is simple: SQL injection. SQL injection, also known as SQL injection, is one of the most commonly known web vulnerabilities, and it's currently listed third on the OWASP top 10 list of web application security risks. In this video, I will teach you all the basics you need to know, from the basics of how SQL injection works, its different types, and I will provide some countermeasures you can implement to protect your application's database yourself. What is SQL injection? SQL injection is part of a broad spectrum of web security attacks that are called injection, where an attacker injects untrusted input to a program, which then gets executed as a command or query, and by this changes the way the application runs. In case of a SQL injection, an attacker injects malicious SQL query code, which results in that the attacker is able to view any data they normally shouldn't be able to have access to. It can also enable the attacker to modify or delete tables or whole databases. But what is SQL? SQL stands for Structured Query Language, and it's the standard language for controlling databases. Many applications actually use external databases to store the information that is shown on the page. And to access this data, the application has to perform queries to that database. There are different types of databases, but many of them actually use SQL or SQL as the query language. Some examples can be MySQL, Oracle, or SQLite. First, I want to give you a short overview of how SQL queries work. They can be used to perform some very complex operations, but for now I think it's enough if we tackle the basic operators like select, from, where, and and. So let's say I have a bookstore and its database stores all the information about all my books, and I want to get a list of all books that are paperback and released. So I'm going to put this query in my database. So the asterisk means I'm looking for all data, and the table where I'm looking for the books is called books. That's why I'm asking for. And I'm also looking for the format is paperback, because that's the format that I'm looking for. And last, I'm asking released is 1, which means released is true. If I wanted to show all the unreleased books, I would put in released is 0. SQL injection means that the hacker injects malicious SQL code into database queries, and they then get executed by the application. But how exactly does this work? Users provide the information the application is requesting from the database, which means most queries are actually dynamic, like the paperback in my query. Instead, I could also ask for hardbacks instead. I just would replace the variable in this case. The problem is that hackers can also insert their own SQL queries into this input field, which could contain some SQL statements with special characters like single quotes, minuses, or semicolons. And that would actually affect the way the original query works. So hackers could also include SQL commands like drop, and the result of a SQL injection attack could be that they could bypass the authentications, retrieve data from the database, or in case they used the command drop, they could also delete tables or databases. How to find a SQL injection vulnerability? Before I show you how a SQL injection attack can look like, I want to show you how to find out if a part of a website is even vulnerable to SQL injection. So first step would be to look for all the cases in which the application could communicate with the database. Some examples for that would be login forms, where the username or password is checked against the database, search engines, where a search string is used to find matching records in the database, or online shops, because most of the time they store product informations in the database. Now, if we found something, we do a first test. We can put a single quote or a semicolon in the field and see if we get any kind of error message. In best case, the error is directly shown in the user face. Otherwise, we have to inspect the source code and the request traffic. And sometimes you find full error messages like this, but in other cases, you could also just find some custom error message or a 500 server error. But in most cases, that means you're on the right track. Alright, now I want to show you a simple example of how a SQL injection could look like by logging in as a user we don't have a password for. For this example, I'm using the Web Security Academy lab by Podswigger, which is a lab that provides deliberately insecure websites where you can try to perform hacks yourself in a legal environment. If you want to try it out yourself, I will put a link to it in the description. So we have this web shop here. We want to log in as the administrator, and obviously we don't have the password for the administrator's account, but luckily with SQL injection we don't need that. So let me click on my account, and here we have a login field. So the first question is this input field, the username and the password input fields, are they actually vulnerable to SQL injection? And to check that out, as I explained earlier, we're going to put a single quote here, and we're just going to put any password, whatever we want, it doesn't really matter. And after that, we're going to click on login. And as you can see here, we get already an internal server error. We can confirm this by opening Burp Suite that scans the HTTP history for us. And we can see here we have a post request for login where we got an error code 500. And down here you can already also see the username and password is any password, just what I put in. So I think we could assume that this login field is actually vulnerable to SQL injection. Now, since we can assume that this login field is vulnerable to SQL injection, we can also assume that the database query could look like something like this. So to actually log in as the administrator, we're going to put here the username administrator, but we won't stop here. We're going to put a single quote after that. That results in that the query only counts the word administrator as the username input value. And after that, we're going to put 2 minuses, since the double minus declares a comment in SQL queries. So the rest of the query will be treated as a comment. So the new query should look a lot like this. And by commenting the query part for the password, we don't really need it anymore. So we can just put any password we want in the password field. And after that, we can click login. We succeeded. So you can see here, we were able to log in as the administrator without having their password. Now, this was a very easy example, but I really hope that this helped you understand how a very simple SQL injection attack could look like. Types of SQL injection. There are different types of SQL injection, and I just performed the so-called in-band SQL injection, which is kind of the classic way, where the results from the attack are instantly displayed on the same platform. For example, we saw the "you're currently logged in as administrator." And subtype of that is called error-based SQL injection, where you get the results of your modified query as a database error string. Another type of SQL injection is called blind injection, where the attacker doesn't get an obvious response from the database, which means that it's a bit more complicated because the attacker has to observe how the server and the app behaves, and by this kind of reconstruct how the database could look like. There's a subtype of that is called out-of-band SQL injection, where an attacker has to redirect the response via HTTP or DNS and then has to set up a proxy or a listening server that actually captures the results of his query. Since this is a bit more advanced topic, I will cover blind injection and out-of-band SQL injection in another video. What are the potential consequences of a SQL injection attack? So now that you've learned all this, you probably start to understand why the consequences of a SQL injection attack can be so bad. Since by doing a SQL injection attack, an attacker can get unauthorized access to database informations, is also able to make changes to the data, and in worst cases even able to delete databases and tables. So we shouldn't ignore how easy it was to log in as another user without their password. But of course it can be easily prevented, but you shouldn't forget to implement countermeasures. So keep in mind, SQL injection can be dangerous and the potential consequences can be massive. The loss of highly sensitive data that is stored in the database is one of the worst possible outcomes of an attack on IT systems. And you wouldn't want your customer data free for grabs on the internet, wouldn't you? So now let's tackle the countermeasures. Luckily, there are countless countermeasures that can be initiated to prevent a SQL injection attack. And there are two things I want to tell you right now that you should always keep in mind when setting up a website. So the first one is proper error handling. Since earlier I told you that one of the subtype of SQL injection is called error-based SQL injection, where an attacker used the error message to perform his injection attack. To make the attacker's life harder, you should always implement proper error handling. Not only will that make your website look better, but it will also improve the security of your application. I'm not saying you should stop displaying error messages altogether, but you should avoid them containing any database details or any other information that could help an attacker. Rather, you should replace them with some generic error messages. The second point I just told you was called input validation. Now, earlier you saw how I logged in as admin and I put some single quotes to bypass the password query. An input validator avoids your app to even process malicious content like single quotes or minuses or semicolons, etc., etc. Another advantage of input validation would be that it also improves the usability because it makes sure that the user puts correct data in input fields. For example, it can check if the email input field actually contains a proper email address. So later the workflow of the app will not be messed up. As you can see here, the input validator checks for basic SQL injection syntax. And by this, my attack attempt gets stopped immediately. Now, the main targets for SQL injection are most of the time username fields, email fields, password fields, but it's best practice to just validate all input data, just in case. And the validator should check for characters like asterisks, single quotes, or semicolons. But you should not rely on input validation on the client side only, because hackers can easily bypass that by making some changes to the code that is loaded in your browser. Now, those were some simple examples for first defense walls against SQL injection, but what if an attacker finds a way to bypass them? Since SQL injection flaws come from dynamic database queries like these, there are two options. Either you stop writing dynamic database queries, or you find a way to prevent input data to affect your database queries. Since option 1 is not really an option in most cases, we'll tackle the second one. And the best way to protect your application is by using prepared statements, also known as parameterized queries. This means that you separate the SQL query from the input parameters, so the malicious input can't affect the query anymore. So that works the following. First, the query is written and sent to the database without any variables. Here you can put a question mark where the variable gets placed later on. And in the next step, the variables get transmitted to the database. This way, the database will treat the variables as string, and not as a command. So to implement that in your code, here's some Java code example. As you can see here, the query contains a question mark instead of a variable, and the variable gets transmitted afterwards with the functions prepare statements and execute query. Now, last but not least, I want to make one final addition to the countermeasures. You can also consider using an object relational mapping layer when implementing. So ORMs drastically reduce the amount of SQL queries, which means that it's less vulnerable to SQL injection attacks. Some examples for that would be SQLi for Java or Entity Framework for C#. ORMs are tools that map objects to database entries and translate them to SQL statements. But you should not rely on that exclusively because they are still translating objects to SQL queries. So that means they're not 100% safe from SQL injection, especially when you're using older versions. Now, to put everything together, I hope you gained a good overview of how SQL injection attacks work and why they're dangerous. And also you should by now know how to prevent opening your app to this attack. Though it's one of the oldest vulnerabilities known, it still placed third on the OWASP top 10 list. And the latest SQL injection attack we know of just happened in 2021. There were probably a bit more, but that's like the latest big attack we know of, since there were 70 gigabytes of user data disclosed. SQL injection is a web vulnerability that has to be taken serious, otherwise attackers will find a way to exploit it. So make sure to always follow best practice by implementing some proper error handling, input validation, use prepared statements, and also consider using an ORM layer. Thank you for watching. If you're interested in learning more about web security, you can always check out my other videos on this topic. Goodbye.